Hey Rock Buddies, it's Papa. Hope all you guys are doing fantastic. Today we're going to talk about the Acadian Orogeny, the Acadian mountain building event, which happened during the Devonian period, which was from 400 million years ago to about 350 million years ago. It followed the Taconic or Taconian orogeny, which we discussed in the last video. So if this video is helpful to you, as usual, please do subscribe. It helps me to know that I'm putting out good content. And so, the Acadian Orogeny. Here we go. The Acadian Orogeny occurred during Devonian time. That would be about 400 million years ago to about 350 million years ago. This is maybe a confusing picture here, so I'll try to explain it. What we have here is the Taconic island arc that has crashed into the mainland during Ordovician time, during the Taconian orogeny. And you'll notice that it crashed from Virginia. This is Virginia, from Virginia north. And because it crashed over an ocean dipping subduction zone, an east dipping subduction zone, the post-drift passive margin sediments became a melange on the continent side, the west side of the Taconic island arc. So during Taconic, the Taconic island arc was tacked on to eastern North America from Virginia north. Okay, here we have North Carolina and South Carolina, by the way. From central to northern North Carolina, all you had during Taconian orogeny or Taconic orogeny was the rifted hunk of basement rock, surrounded and actually covered, even though it's hard to see, by post-drift passive margin sediments. No volcanic island chain formed here. Now, from southern North Carolina through South Carolina, Georgia, and Alabama, during Taconic, you had an island arc chain formed with a west dipping subduction zone, a continent dipping subduction zone. So the melange was formed on the east side, or the ocean side, of the volcanic island chain. But this volcanic island chain did not crash during Taconic. It formed and it eroded some, adding to these post-drift passive margin sediments, but it did not crash. It's out in the ocean, as is this rifted hunk here. So that's the way. Okay, and once again, how do we know that during the Taconic orogeny, island arcs crashed from Virginia north, but they did not crash from North Carolina south? Because from Virginia north, we have this big delta called the Queenston Delta. In this picture, the Queenston Delta is underneath this green part, and I'll tell you about this green part in a minute. But we don't have any Queenston Delta deposits from Virginia south. That's how we know there was no crashing here. There was crashing here. Okay, now let's switch to the Acadian orogeny, the Acadian mountain building event, which occurred during Devonian time, which was 400 million years ago to 350 million years ago. Here is what's called the Acadian microcontinent. Okay, it wasn't an island arc, it was much bigger than an island arc, and I ran out of room to draw it over here, but it was quite large. It was a small continent side. It's approaching the mainland of ancient eastern United States and from Virginia north, not Virginia south. The Acadian microcontinent did not crash in from Virginia south. So it did crash in here. And these Acadian mountains, I haven't shown it crashing yet, but it did crash. So let's assume it's crashed. And its erosion sediments they covered up the Taconic Queenston Delta, and they became this massive Catskill Delta, which was even bigger than the Queenston Delta. And the Catskill Delta, like the Queenston Delta, was made first of mud and silt, then sand, and then pebbly sand on top of that. And because during Acadian Orogeny times, Devonian times, the climate was dry, a lot of these Catskill Delta rocks are very reddish, which means the iron in them became oxidized with exposure to air. Okay, now what we have here is the Acadian Orogeny Phase 1. Okay, so what was the Acadian Orogeny Phase 1? Phase 1 of the Acadian Orogeny was the Acadian microcontinent crashed into the mainland from Virginia north and eroded its sediments into this new Catskill Delta. In a second, I'm going to show you what happened during the Acadian Orogeny Phase 2. Okay, we've looked at Acadian Orogeny Phase 1, or Part 1. Now, let's look at Acadian Orogeny Part 2. But as you'll recall, in Part 1, a huge Acadian microcontinent crashed here from Virginia north during Devonian time. It eroded its sediments into this large basin called the Catskill Delta. That's Part 1. Part 2, in Part 2, all this material that was up here, all this terrain, a whole bunch of the original Taconic island arc that had got tacked on, plus virtually all of the Acadian mountain terrain slid down this way to right here. This is that material right now that once was up here. That was the big activity of Acadian Orogeny Part 2. Now, that sounds strange that one huge block of terrain would slide down relative to another, but if you look at the San Andreas Fault in California, that's exactly what's happening right now. Everything on the west side of the San Andreas Fault is moving north relative to everything on the east side. So this sliding motion, which they call strike-slip motion, is a common occurrence in the process of these mountain building events. And it was a doozy here during the Acadian mountain building event. Remember the Dahlonega gold belt terrain that formed during Taconic and did not crash during Taconic? But when all this material slid down, it pushed the Dahlonega terrain onto the continent. And look here, Taconic terrain. This is the Taconic island arc material that crashed up here. It also slid down. Here's the Acadian microcontinent, what's left of it. It crashed up here, it slid down, and now we call it the Carolina terrain. It's not up here anymore, it's down here. In between this Taconic island arc material and the Carolina terrain, the old Acadian microcontinent, was an ocean basin that is now called the Cat Square terrain. Now, this Taconic arc material that slid down along the Brevard Fault Zone is what we now call our Inner Piedmont terrain. Let's look at the two different kinds of faults that can occur to help explain this sliding motion. And by the way, this Frankenstein scar is the fault along which all this material slid from up here to to down here, about 500 miles plus or minus, maybe 300 to 500 miles. This Frankenstein scar is called the Brevard Fault Zone down in Georgia. It has other names in Virginia. I'm not sure exactly what they are, but it does, most geologic maps show it going up through Virginia. Okay, during Taconic, when the island arc was pushed onto the continent like this, that's a thrust fault, and it looks like this. Here's the continent, here's the Taconic mountains thrusting to the west. It's a thrust fault. This, on the other hand, which represents the Brevard Fault Zone, is a strike-slip fault. You can see the fault plane, the place where the fault is pretty much vertical here, whereas here it's horizontal. The fault surface is horizontal. And this is a strike-slip fault, and that's exactly what happened during the Phase 2 of Acadian. Everything on this side, the east side of this Brevard Fault Zone, which was up here, slid to the southwest relative to everything on the west side, which was this. As all this material slid southwest along the Brevard Fault Zone and its counterparts, plutons, granite plutons, were emplaced all up and down the east coast, all the way down into North Carolina. That's because during the strike-slip motion, it generated a lot of friction, a lot of pressure, and a lot of heat that melted the granite and granite gneiss of the basement rock and the mainland and reformed it as granite in place during the Acadian mountain building event. Now, I believe that not all the Taconic island arc material that crashed up here came down here during the Acadian Orogeny Part 2. Some of it stayed up here. For example, in New York, I think the remains of the Taconic mountains are in fact what was left of the Taconic island arc. But most of it did slide down here along this Brevard Fault Zone. And of course, we call all this material the Inner Piedmont terrain. It's all island arc material slid down from up here on the Brevard Fault Zone. So what does that mean? That means that this material here, which is down in Georgia, where did it start out? Where did it crash? It crashed up in here, in Virginia and Maryland. That will be of interest to my rock buddy, Spiritual Path Seeker. How about this material that's now in southern Virginia? Where did it originally crash during Taconic and the Acadian Orogenies? Well, likely way up here somewhere. And it's very interesting, if you look at this material, some of the material in here, you will find a unique kind of granite called an orthosite that has a lot of sodium/calcium feldspar in it. Where do you find a whole bunch of an orthosite? In another location? Up here in the Adirondack Mountains and up here in Newfoundland area. That may be a bit of a smoking gun. So let's look at another smoking gun. Interesting enough, let me straighten this out here. Notice how from Virginia north, there's this big gap in the terrain. There's nothing here, not much, just a few stickouts. And notice from Virginia south, there's this huge wad of material. We're used to that because we're so used to looking at the eastern contour of the eastern United States, but doesn't that look like more than just a coincidence? And doesn't that kind of tell you that it is very likely that what was here is somewhere else, and this is the somewhere else that it is? Now, that may seem like a weak piece of evidence, but As many of you know, the idea of plate tectonics was first introduced by a fellow by the name of Dr. Wexner, who noticed how the western bulge of Africa looked like it fit into the gap in North and South America way down here, just like a puzzle piece. So we have a precedent for that kind of idea. Okay, rock buddies, so there you have it, the Acadian Orogeny, the Acadian mountain building event. My next video will be about the third and final mountain building event in the eastern United States, and that would be the Acadian Orogeny. Now, if this one on the Acadian Orogeny has been helpful to you, I hope you will please subscribe, and I'll be very appreciative of it. Until the next video, this is Papa wishing all my excellent rock buddies happy rock hunting, and Papa out.